A lot of questions were asked by you based on, they were asking how to find out fields due to a combination of charges. If there is a combination of charges, then how do we find out the fields due to that combination? So let's consider this combination here. This is x-axis, this is y-axis, and we have two charges. And let's consider a point P someplace. Point P. This is point P. Now, if we find out field due to Q1 at point P, it will be something like this. If we find out field at point P due to Q2, it will be something like this. And let me draw the point P again. There will be field due to Q1, that this is E1, so let me call this as E1, and field due to Q, this is E2, so let me also call this as E2. So what will be the resultant field? So the resultant field is always the vector sum. Parallelogram law, do you remember the parallelogram law from the vectors in class 11th? So vector sum, and if you know the angle theta, it's very easy to find out the vector sum. So that is E equals to root under E1 squared plus E2 squared plus 2 E1 E2 cos theta. And likewise, you can find out resultant due to 3 charges or 4 charges or 5 charges. You can start adding them in vector combinations, or you can also resolve them along, you can use vector resolution. Along x-axis and y-axis. That is also a way to do it. But we have a few simple problems to discuss. So consider this problem. Here, 2-point charges 4q and q are placed 30 centimeters apart. At what point on the line joining the two charges will the net field be 0? So let's take a line first, and you have 4q and you have q, and they are 30 centimeters apart. So 30 centimeters in SI unit would be 0.3 meters. Please take care of that. And in this line, these two charges divide the line into 3 regions. So this is region 1, this is region 2, this is region 3. So let's talk about the 3 regions separately. And let's start with region 1. Positive charge 4q away from the charge, positive charge q away from the charge, and you will see that the two fields are in the same direction, so they will be added in value and there will be no cancellation. Let's get to region 3. Positive charge q away from the charge, that is the nature of field. Positive charge 4q away from the charge, again that is the nature of the field, and again since they are in the same direction, it will be added. No cancellation whatsoever. Now let's come to region 2, taking any point in the region, and due to 4q away from the charge, obviously due to q away from the charge, and there is a possibility of cancellation, may cancel. So how do we find out where they cancel? Let's take this distance x and this distance as 0.3 minus x. Please remember the total distance. The total distance between 4q and q is 30 centimeters or 0.3 meters. So let's call this field as E1 and let's call this field as E2. And what would E1 be? E1 be k 4q upon 0.3 minus x squared. What would E2 be? E2 will be KQ upon x squared. Now since we are talking about a possibility of cancellation, so E1 must be equals to E2 in value obviously, and if we equate these two, we will have 4 upon 0.3 minus x squared equals to 1 by x squared. Now we are not going to cross multiply this, that is going to be a waste of time. What do we do is we take simple roots. 2 upon 0.3 minus x equals to 1 upon x. Now I know that there is a possibility of a plus minus here, but the minus will not satisfy, and that will not satisfy, that has a reason, we'll discuss sometime later on. That is a mathematical part of it. But now we cross multiply and the solution is here. 2x is equals to 0.3 minus x. So that gives us x is equals to 0.1 or 10 centimeters. 10 centimeters. Okay, so what is the distance x? Distance x is 10 centimeters. And what will be 0.3 minus x? That will be 20 centimeters. And this is how you solve this problem. Moving on to next problem. It is a bit more difficult one. So let's see. Charges 2q, this is charge 2q, and minus q, 2q are placed at, where is 2q placed? 2q is placed at a comma 0, and where is minus q placed at? It is placed at minus a comma 0. Find the coordinates of the point at which the electric field is 0. Again, same thing. You have to divide your line into regions. So let's say this is region 1, this is region 2, and this is region 3. Now let's start working on region 2 first. Taking any point here. For the negative charge, the field is towards the charge. For the positive charge, the field is away from the charge, and no cancellation. You can see no cancellation possible. Let's take another one. This region here. For the negative charge, it is towards the charge. For the positive charge, it's away from the charge. And since they are in opposite directions, there is a possibility of may cancel. Likewise here in region 3, let's see, in region 3, due to positive charge away from the charge, due to negative charge towards the charge, and since they are in opposite directions, again they may cancel. Now let's look out for region number 3 first. Region number 3, this is minus q, this is 2q, and here we have a point in region 3. Now let's say this distance is r1 between 2q and point P, this is point P, and between minus q and point P the distance is r2. As you might see, the field due to 2q will be away and due to minus q will be towards. So what will be field due to 2q? It will be k 2q upon r1 squared. And what will be field due to minus q? It will be kq upon r2 squared. Now what is the possibility of cancellation here? How do we cancel it? So if we cancel it, we have to equate the values. So equating the values, we'll get 2 upon r1 squared is equals to 1 upon r2 squared. And solving it, or exactly just looking at it, you will have r1 squared is equals to 2 times of r2 squared. Now see, this is the problem here. This is not possible. And why is this not possible? Because you can see r1 is less than r2. So the square of R1, being 2 times the square of R2 is a possibility that we are not going to accept. Now let's look at region 1. Region 1. Or let me change the page. This is minus q, this is 2q, and this is what we are calling as region 1. So due to minus q, the field will be towards, obviously due to plus 2q it will be away. Let's say this distance is r1 and this distance is r2. So what will be the field due to minus q? It will be kq upon r1 squared. What will be the field due to 2q? It will be 2kq upon r2 squared. Now we have to equate them because the magnitudes are equal and there is a possibility of cancellation. So 2 upon r2 squared is equals to 1 upon r1 squared, and that will give us r2 is equals to root 2 times r1. Now that is very much possible, because in this diagram itself you can see that r2 is greater than r1. That's very much possible. So r2 is root 2 times r1. Now r2 is root 2 times r1, but we need another equation to solve it. So what would be the other equation to solve it? The other equation to solve it is by looking at the distance between the two charges. What is the distance between the two charges? The distance between the two charges is 2a. Hence we can have r2 minus r1 equals to 2a. So that is equation number 2 and this is equation number 1, and you can easily solve the two equations to get the values of r2 and r1.